Good morning everyone. I am Ganga Devi from SFR College. Through this video we are going to see what is deadlock in operating system. So throughout this video we are going to see what are the characteristics that are involved for deadlock situation and how we will handle it, especially we are going to see the deadlock prevention and deadlock avoidance. So what is a deadlock? So deadlock is a situation, it may occur when several processes are competing with one another for a single resource simultaneously. If they are asking for a single resource at a time by holding some other resource in their hand, then surely a deadlock situation may occur, which may be resulted in blocking itself. That is, all the processes of the system is getting stuck. So what are the characteristics that are involved for deadlock? So there are 4 characteristics. One is mutual exclusion, that is only one process at a time can access one resource, that is the resource should be non-shareable with every processes. At that moment deadlock may occur. Hold and wait, that is whenever a process is holding a resource in its hand and it is asking for some other resource, it is waiting for some other resource, at that moment deadlock may occur. And no preemption, if I am a process, I am having a resource with me and I am waiting for some other resource, but I am not ready to release the resource that is in my hand, means at that moment no preemption may occur. And circular wait, if more than 2 processes are involved and each one process is waiting for the other process in a circular manner holding a resource in its hand, at that moment, that is hold and wait in a circular manner, then it is called as circular wait. So here we are having a graph methodology which is used to detect whether the deadlock is occur or not. So this graph is containing a set of vertices and set of edges. The set of vertices may be a process set, that is processes will be symbolized like a circle, and resources set may be symbolized in a square manner, but if the resource is containing some more number of instances, then that may also be defined in the symbol. Okay. The edges may be of 2 types, one is the request edge and another one is the assignment edge. Requesting edge means a process is requesting for a resource. Assignment edge means that particular instance of the resource is assigned to the process. Okay. So this is an example for a resource allocation graph. Here if there is no cycle in the graph, then there is no deadlock. Okay. But see this image, there is a cycle between P1, P2 and R1 and R2, right. So if you are having, if it is involving a cycle, then there may be a deadlock may occur, surely there may be a deadlock situation. But also in the situation, simply saying in which situation means that when there is only one instance of a particular resource, then deadlock may be surely occur. But here look at this image, here a cycle is occurred, but the cycle may be, that is the deadlock may be getting released whenever the process P2 or P4 is completing its task, it may release the instance. At that moment there is no deadlock situation. Right. So these are the methods of handling the deadlock. If our system shouldn't getting into the deadlock means, then we have to follow deadlock prevention methodology and deadlock avoidance methodology. Even though we are preventing it, if it is occurs means, then we have to follow the deadlock detection methodology and deadlock recovery methodology. Okay. So let me see what is deadlock prevention. So in deadlock prevention we are going to eliminate the characteristics that are involved in deadlock. So the first one is we are going to eliminate the mutual exclusion condition. So that is, but eliminating the mutual exclusion condition is not possible, because in every situation there may be a resource which is non-shareable, example printer, mutex locks, etc. And if you want to eliminate the hold and wait condition, at that moment what we are going to do is we are going to allocate all the resources in the initial stage itself. Otherwise, we have to release the holding resources whenever the particular resource is not available to allocate to us. At that moment, hold and wait will be getting eliminated. So next one is eliminating the no preemption characteristics. For eliminating the no preemption, the process should release all the resources currently being held. That is, the process should preempt itself. Otherwise, the process should forcefully preempt the resources from the some other waiting process. Okay. In these two methodologies, no preemption can be eliminated easily and deadlock may be avoided. Last one is we have to eliminate the circular wait. Here the procedure we are going to follow is we are going to number all the resources. Okay. And if we want to allocate some resource, the resources should be we should ask for the resources in an increasing order or in decreasing order. If you are following increasing order means if I am allocating with resource R4, then that particular resource process, that is I, can't request for the resource R2. Okay. So, on allocating R4 it can't access R2. That is the situation. Okay. So, next one is deadlock avoidance. If we want to avoid the deadlock situation, we have to check whether the system is in safe state or unsafe state. If the system is in safe state, then there is no guarantee for any deadlock. Okay. That is, there is no guarantee for deadlock occurrence, that is it will not occur. If the system is in unsafe state, then there may be some possibility of deadlock occurrence, it also may not be occurred. Okay. For avoiding the deadlock, we are having an algorithm called Banker's algorithm. This algorithm is applicable whenever there is multiple instances available for a particular resource. So, this algorithm is used to test the system whether the request by a process can be allocated or not. That is, it is going to check whether the system is in safe state on accepting that request. So, it needs some prior informations for this algorithm. So, we need a maximum need of the resources by the process and we need the number of allocated resources already allocated to the process and we are in need of the availability of the resources. These are the informations we are in need in prayer. Okay. The algorithm involves two methodology. One is safety algorithm. It is used for finding out whether the system is currently in safe state or not. So, it checks the system for safetiness. Okay. If the system is safety, then we are going for resource request algorithm. That is, if the system is requesting for a resource, at that moment this algorithm checks whether the request is less than the need. If it is so, then no problem, but if it is greater than need, then error condition may occur. Okay. If the request is greater than available, then what may happen? There is no available resources, right. So, the process should wait until the resource is available. Okay. So, if the request is in condition, that is it satisfies all the conditions, it is less than need, it is less than available, then it check the system, if it is safe, the resource is granted. Otherwise, the process should wait until the available condition occur. Okay. So, the conclusion is, in the system deadlock may occur in some situation, but it's not a frequent task, it may be occur in often. That is, a deadlock may occur once in a year, for example. Okay. So, if we, even though we are trying to avoid it or prevent it, but if it may happen in some situation, at that moment we should go for deadlock detection and we have to recover the system from the deadlock. But one more solution is also there, that is, we may ignore the problem itself, that is, we can pretend that there is no deadlock in the system, simply we should avoid it. So, Unix and Windows are following the same methodology, that is, they are ignoring the problem only. Okay. So, thank you for watching.